The dog days of summer, the hottest time of the year, is when flying operations drastically increase. Whether you fly for recreation, corporate, commuter, or air carrier operations, a pilot knows that the moment you begin your walk around and then taxi for takeoff, you subject your body to extreme heat. The human body operates best when its core temperature is at 98.6 degrees. Fluctuations in temperatures during flight are the cause for basic physiological responses in your body known as thermal stress. Over a period of time, it is this thermal stress that becomes a significant factor in terms of pilot fatigue and impaired performance. Since the cockpit environment presents several kinds of physiological and psychological stressors anyway, it's best to learn how such elements can impact pilot functions. Without knowing the scientific term, pioneering aeronauts understood thermal stress as their balloons ascended in the air. Pilots in open cockpit aircraft recognized temperature extremes while trying to compensate for added wind conditions. Thanks to the invention of heated and pressurized cabins, the technology of today's aircraft eliminates the chilling temperatures once associated with flying. In the early days of aviation, as interest in temperatures became more paramount, especially with regard to tropical and desert-like regions, heat stress became a major problem for pilots. Humidity, temperature, and radiant heat contribute to a body's ability to manage heat loss and gain. Closed cockpits produce a greenhouse effect on the ground and during periods of low-level flight. Even with the technical sophistication of air-conditioned aircraft, heat stress continues to be an important concern because the capacities of most onboard cooling systems are deficient on the ground and at low altitudes. Post-accident survival situations can also expose a pilot to hot desert or tropical conditions. Pilots are exposed to varying levels of thermal stress, and their responses to such stress differs among individuals. To better understand the factors that contribute to personal thermal stress, one first must acknowledge the following aspects. What is your personal range of response to heat? What are your options for reducing unacceptable thermal stress? The human body is able to maintain a heat balance by 4 different methods: conduction, convection, evaporation, radiation. Conduction is where heat is transferred by having contact with another object. This can happen when a pilot sits down in an aircraft seat that is already hot. Convection occurs when heat is transferred by liquid or a gas. This can occur when an aircraft engine warms the outside cold air for comfort in the cockpit. Evaporation occurs when liquid changes to a gas. Energy or heat is required to produce this change. Whenever a body perspires on the flight line, eventually the perspiration evaporates to cool the skin. Evaporation occurs during exercise and in a hot cockpit. Radiation is a method where heat is transferred from an object to another object through the air. When you sit in the sun and can feel the transfer of heat from the sun to your skin. So what happens to you when you expose yourself to extreme temperatures of heat? The factors that affect human tolerance regarding temperature stress are very individual in nature. There are many individual aspects that should be taken into consideration. The type of clothing worn should be suited to the weather conditions you are working under. What about the amount of physical workload or activity exerted? Pilot workload can vary from commercial pilot, aerial applicator, military fighter pilot, or that of a glider pilot. The amount of physical activity exerted during flight is a significant factor when considering levels of thermal stress. What are the environmental conditions? When examining the internal and external environment of the cockpit, what are the conditions? Direct solar radiation, greenhouse effect. In the cockpit, there may be indirect solar radiation where heat is reflected. Be aware that whenever you operate an aircraft in extremely hot environments, the temperature does have an effect on your flying performance. When flying performance deteriorates, it is related to both physiological and psychological factors. There are several predisposing factors that as a pilot you need to be aware of when flying in hot conditions. Advancing age, female gender, history of heat-related illness, poor physical fitness, lack of ability to acclimatize to heat, hydration, consumption of caffeine and alcohol, fatigue, being overweight, obese, or having sweat gland abnormalities. Whenever a pilot is exposed to hot temperatures in the cockpit, you can be certain that performance will be affected. See if you can identify at least 6 performance errors due to heat exhaustion in the cockpit.
November 734 Echo Zulu, contact approach 124.3. November 734 Echo Zulu, traffic 3 o'clock, 4 miles westbound. November 734 Echo Zulu, did you copy traffic?
Looking for traffic.
November 734 Echo Zulu, expedite climb to 5,500, reference opposite direction traffic. November 734 Echo Zulu, I told you to climb. Turn left heading 300 immediately.
Say again?
November 734 Echo Zulu, turn left heading 300 immediately. November 734 Echo Zulu, my radar shows you right of course. November 734 Echo Zulu, you're far right of center. Initiate go around.
If you cited delay of reaction time, increase in error rate, decrease in attention span, poor response to emergencies, deterioration of physical stamina, impairment of pilot's ability to handle cockpit management, then you're on target for identifying possible heat-related symptoms. One of the main factors contributing to problems in pilot performance during hot conditions is the loss of body fluids. There are 2 deficiencies in the human body that create this dehydration problem. First of all, as humans, we do not have the capability to replace fluid rapidly. Secondly, we are poor at judging our individual need for fluids and maintaining proper body fluid levels. Dehydration is due to the production and evaporation of sweat. This is perhaps the largest concern facing pilots in the cockpit. What is the appropriate amount of water to drink? The recommended intake from health authorities is 8 8-ounce glasses daily, which is equivalent to 2 quarts. The body absorbs water at an average rate of 40 to 50 ounces per hour. How often you drink will depend on your workload, your individual physiology, the inside-outside temperatures, humidity levels, temperature of the drinking water, and the amount of alcohol or caffeine you have ingested. Alcohol and caffeine products are diuretics, meaning that they cause an increase in urine production and result in fluid loss. As an important reminder, thirst is not a reliable indicator of your hydration status. Most often, when you feel thirsty, you are already dehydrated. Taking a couple of drinks from a water fountain may send signals to the brain that your thirst has been quenched. This may not be the case. What it does mean is that the next time you get an indication from your internal thirst mechanism, you are already fluid deficient and therefore should immediately begin proper fluid replacement. It's better to have small amounts of water than nothing at all. Try to use a water container that allows you to measure your daily intake of water. Here are some suggestions to help you in conquering dehydration. If possible, reduce your workload activity. Hydrate. Cool water, water that's about 40 degrees Fahrenheit, is the optimal fluid choice to drink. But just drinking water can become boring. Alternate lightly flavored beverages with water. A good drink is to mix 2 parts water with 1 part sports drink. When trying to prevent dehydration, the following is a list of things to avoid. Sweet sodas or juices, due to their high sugar content. Drinks that contain caffeine. Alcoholic beverages. And undiluted athletic beverages. In an effort to replenish the body's fluids, what consideration should be given to one's salt intake? The American diet is so heavily laden with salt that additional amounts are generally not required. Heavy exercise in extreme heat could cause a need for additional salt, but for the average pilot, increasing one's salt intake is not necessary. One important factor to be aware of with regard to fluid intake is that in keeping hydrated, you help your body in being able to acclimatize to warmer temperature environments. Being hydrated ensures a smoother acclimatization process. Getting adjusted to a warmer climate usually takes about 10 days. For example, a pilot flying from Denver to Tampa Bay for the weekend may have a hard time adapting to the heat and humidity. The body may sweat more in an attempt to cool down. Here are some extra tips to aid in the acclimatization process. Minimize ramp time. Be aerobically fit. The more physically fit you are, the better your body can adapt to heat. Have fluids readily available if needed. And as a reminder, try to drink from a container that can help you measure your daily fluid intake. Another measure to take when trying to acclimatize is to wear appropriate clothing that fits the weather condition. The key to properly acclimatizing and flying safely is to plan ahead for environmental conditions that you could possibly encounter during your flight. If weather conditions change, it's the pilot's responsibility to know the problems associated with environmental changes and know what measures to take to enhance safety as well as comfort. Let's review some of the basic information with regard to temperature extremes of flying. The body maintains heat balance by 4 different methods: conduction, convection, evaporation, radiation. The factors that affect human tolerance regarding temperature stress are very individual in nature. Personal elements that affect temperature tolerance include type of clothing worn, amount of workload exerted, environmental conditions. One of the most important reasons that pilot performance deteriorates is due to the loss of body fluids. It's important to remember that as humans, we do not have the capability to replace fluid rapidly. Besides that, humans are poor at judging our need for fluid and being able to maintain proper body fluid levels. Health authorities recommend a daily water intake of 8-ounce glasses 8 times a day. As a final reminder, thirst is not a reliable indicator of a person's hydration status. Try to drink from a container that allows you to measure your daily intake of water. Drink when you can, even when you're not thirsty. There are numerous occupations that subject the human body to extreme temperatures, and the flying environment presents such a setting for a pilot. By understanding the physiological responses to thermal stress, Pilots can plan ahead and take necessary precautions to avoid extreme temperature effects on the body. Keep in mind the advantages of maintaining the body's core temperature and try to anticipate and prepare for potential temperature deviations. Being able to acclimatize to hot environments reduces your risk and occurrence of thermal stress disorders.